Hi, I'm Grady Simmons with the International CCS Knowledge Center. We're an organization dedicated to sharing knowledge and information to help advance the development of large-scale carbon capture and storage projects worldwide. As part of our ongoing CCS Knowledge Spotlight series, we're exploring some of the promising new carbon capture technologies that are reaching the market and discussing the opportunities and challenges that are emerging as these products look to scale up and be applied across heavy emitting industries on the journey to reaching net zero greenhouse gas emissions. Today, we're learning about the technology behind Svante, a carbon capture and removal solutions provider based in Vancouver, British Columbia, Canada, that has developed a unique adsorption process for removing CO2 from industrial emission sources or directly from the atmosphere with their solid sorbent-based filter technology. We're fortunate to be joined by Matt Stevenson, Svante's Chief Revenue Officer, who will tell us more about Svante's carbon capture and removal solutions and some of the key projects they're involved with across North America. Thanks for taking the time to chat with me today, Matt.
Great to be here, Grady. Looking forward.
So yeah, maybe let's start with that. As you know, a lot of the large existing CCS projects around the world have been based on liquid amine-based capture process. Can you explain in a nutshell how Svante's technology works and some of the key maybe differences between Svante's technology and the liquid-based amine systems that are out there?
Yeah, absolutely. So liquid amines have been around for, well over half a century in use around the world for acid gas separations generally, and more recently for CO2 separations, post-combustion capture specifically. So it's been great to see that technology evolve and be adapted to post-combustion CO2 capture, point source CO2 capture. Our technology is really a second generation technology. So building on the momentum in the CCUS space, but developed from the ground up beginning about 16 years ago on a totally different approach. So we're based on solid adsorption and a relatively unique way of doing solid adsorption. We use a proprietary nano-engineered sorbent material that has a very high capacity for CO2, and we form that into what we call a structured adsorbent filter bed that has a very high loading of active material, but allows for a very rapid process, low pressure drop, and the ability, let's say, to do the adsorption, desorption, regeneration cycle that you need to do to capture the pure CO2 in a very rapid fashion. So instead of hours or several minutes for point source capture, we get that down to less than 60 seconds. That means a very small inventory of adsorbent powder, compact equipment, and low capital cost, efficient process. And beyond that, what's interesting about the technology is by using what's called a physisorbent, really benign solid state material, and designing from the ground up, all of the materials, equipment, and process that go around that, we end up with an intrinsically sustainable technology. So this is a technology that's, I like to say, environmentally responsible by design, both in terms of its production, fabrication, manufacture, but also in terms of its operation in the field. So we have a number of advantages in terms of the absence of secondary emissions. You're taking CO2 out, but you don't want to be adding anything back in to the atmosphere. That's really important to us. And so the advantages we have around being a solid state material that doesn't add any new emissions to the atmosphere, I think, are really important. And so the way the process works, we really enable the use of low value waste heat. So if you have a hard to abate industrial emission source, and think about a steel plant or a cement plant or other types of similar facilities, you often have very low grade heat around. And we have a unique way of monetizing that heat, let's say, and reducing the overall energy consumption. So there's a number of additional advantages in terms of our ability to handle the intermittency you see in hard to abate industries. Not every industry runs 24/7, and you need a technology that can enable that. And also in terms of scalability, it's a really interesting proposition. Being a solid state technology with a standardized design around our filter beds and our machines, the actual machines that capture the CO2 that those filter beds go into, we enable a lot of modularity and repeatability. So that increases the scalability of the technology, not just in terms of the size of capture plants, but the number of capture plants to meet global demand. And it also increases the economics, let's say, of the installation on larger plants in the field.
think you touched on it earlier, but it sounds like one of the key advantages really is around energy use. You know, a lot of the large existing projects have a very high energy requirement in order to operate the system, and Svante's is more efficient from that perspective.
Yeah, you have to look at it on a holistic basis. You can't just look at the adsorption process or the absorption process in isolation. You have to think about actually installing these facilities in real plants for real emitters. And that's where, our adsorbent material and our process shine because of our ability to use waste heat to lower the overall energy consumption of the plant. Without the use of that waste heat, we tend to be competitive, in the same ballpark as the existing liquid amine technologies and others. But with that advantage, we can often have material reduction in the energy consumption.
Yeah, interesting. So, and you just talked on it. Let's pick up on that in terms of real world application. I know you guys have a number of projects underway with some clients, and are doing work and field testing with your equipment right now. Can you explain a couple of your key projects that are out there operating at this point?
Sure. I mean, over the company's been around, as I said, for 16 years. I would say the first 10 years were really in the lab, figuring out the technology, how to get the right sorbents, how to form those sorbents into filter beds, how to design a process around it, and come up with basic equipment concepts, and even come up with basic manufacturing processes. Since about 2017, though, we've really been on the demonstration pathway, and then I would say, since 2021, we've really been on the commercialization journey. So that the development pathway culminated with the commissioning of our first, I would say, industrial scale pilot plant. It's a 30 ton per day or about 10,000 ton per year capture plant with Cenovus Energy in Saskatchewan, operating on a natural gas boiler. That plant is still in operation today, so it's been running since 2019, giving us lots of great data. We have a second of a kind plant of the same size, approximately. It was just commissioned this summer with Chevron down on their operations in Bakersfield, California. That project was also supported by the U.S. Department of Energy. The difference between those two facilities is the first one was using a sorbent that's applicable for lower concentrations, that does have a chemisorbent aspect to it, let's say. And this latest facility that we turned on with Chevron in California is based on our go-to-market metal organic framework material. That is the physisorbent we're using for our industrial point source applications. So it's really the latest and greatest in terms of our go-to-market solution for hard-to-abate industries. So those are the two larger pilots that are really critical for demonstrating the technology. We have a number of smaller units. We have a unit that's running just under 1 ton per day at a cement plant here in Richmond, British Columbia, at Lafarge's cement plant there. And that's collecting great data around the types of challenging contaminants, particulates, the things you see in real cement flue gas that can be a challenge for some technologies, and we see good durability and resilience from our technology in that environment.
Interesting, and that kind of leads into my next question. As we've seen with a lot of our work on large projects like the Boundary Dam project in Saskatchewan, the characterization of the flue gas is a big challenge and a big learning that came out of that project in terms of being able to address that and having to pre-treat flue gas before it goes into the capture process, or else it can cause all kinds of issues. How does that compare, or how does Svante have to deal with that in terms of different kinds of emitters and emissions?
Yeah, as you know, in your experience, it's really specific to the flue gas. So you do have to take that into consideration. But we are benefiting now from the several decades of work that's been done around the liquid amine technologies, including projects like Boundary Dam. So there's a lot of learnings that's come from that. It's certainly about the ability to control those contaminants that can have an impact on the flue gas, whether it be SOx or NOx, whether it be things like fine particulates, PM 2.5, those sorts of things. And so we rely on that knowledge base quite a bit, and we look to, as a first pass, design the pre-treatment to provide a similar level of performance as you would see in most carbon capture systems. And then from there, we think about how we can relax that, how our system, for instance, enables more resilience and less cost invested in the pre-treatment systems. But for our first of a kind implementations, you're trying to minimize risks everywhere you can, and so we're relying on a similar level of pre-treatment that you would see in those systems. I would say that one particular area where the technology has an intrinsic advantage is around fine particulates. So larger particles tend to get captured in the pre-treatment equipment, whether it be a direct contact cooler or a quench tower, or systems upstream of that like a baghouse or an ESP. But the fine particulates tend to still get through the system. And in liquid systems generally, that does create the risk of aerosols, where fine particulates are going into a solvent and can cause some carryover. There's technologies to address that, of course, but everything's a matter of CapEx and OpEx trade-off. And for us, those fine particulates tend to just pass right through our system. And that's where operating experience like we have at the Lafarge unit is so important, to be able to show that to our customers.
Yeah, interesting. Maybe talk a little bit about, I guess, just the path forward and what some of your expectations are around, I guess, the scale up of the technology into larger systems. Something like looking at Boundary Dam and Quest and some of the other existing projects where there was fairly large scale up in the case of Boundary Dam from 7,000 to 1 from a pilot up to a facility capable of capturing 1 million tons a year. Lots of challenges that come with that. How do you think, some of that experience and learnings might help Svante in terms of its longer term ramp up, working with clients and building facilities that'll be capable of meeting the demand that obviously is going to be huge in the coming years?
Yeah, I'll maybe separate my comments into two topics. So first is the scale up of the technology itself, and the second is around the scale up of the business to support that kind of growth in those
Right.
larger plants.
Yeah.
So first on the technology piece, as a solid state technology, and the way we do our adsorption within these structured laminate channels, we have an intrinsic advantage around process scale up, and it looks something like this. Once you have a full length adsorbent bed and you've fixed the velocity of the gases, the composition of the gases, the conditions of the gases, that adsorption process is going to behave exactly the same at a small, 1 ton per day scale as it will at a very large scale, because all you're doing is you're taking that one channel or that one section of bed and you're just repeating it multiple times. The velocities, the adsorption phenomena, the mass transfer, all of that stuff is exactly the same. It's scale invariant, which is an intrinsic advantage over gas liquid contacting systems, which do have these scale effects that are a little bit more complex. So when it comes to the fundamental adsorption process, we have really good dynamic models that predict performance, and then we have all of our test stations being subsequently larger, all the way up to our larger pilots that then validate that that is in fact the case, that you see that scale invariance of adsorption performance. The things that do vary with scale is as we get larger machines, you have larger mechanical devices, so there's mechanical scaling, and you have different flow distribution. You have to manage larger gas flows, and you have to still achieve the same type of uniform distribution of gases. And you do have a harder sealing challenge. You have larger areas to seal in our adsorption machine. And our approach there is prototyping. So we've already built and are running a full-size machine prototype here in our facilities in Richmond that allows us to test those things, in particular the gas sealing and mechanical, the operation of the machine, et cetera. So that's the way we've addressed that. We have some intrinsic advantages around being a solid state technology with the way our process works, so that we can test full length beds at subscale. But for the other items, we rely on prototyping. You've got to build it. We do a lot of simulation, a lot of engineering, a lot of FEA, a lot of CFD, but at the end of the day, you've got to build these things and validate those models. And that's our approach. And we've been fortunate, maybe switching over to the commercialization aspect, been fortunate to have the resources to do that. So raised about 500 million USD total capital, just over that, in our history, and most recently a $318 million USD Series E round closed last December, which has put us in a position to be able to do this type of prototyping, de-risking work, several years ahead of when we'll do our first installations. So that gives our customers and funding partners quite a bit of confidence around our ability to buy down that risk technically. The other aspect of that level of investment is just the growth of the company. So we've decided to move ahead and started earlier this year a full-scale manufacturing facility to build the filter beds. It's going to be, over $100 million USD manufacturing facility. It's currently about halfway through construction as we speak. And it's going to have the capacity to equip 10 1 million ton per year capture plants every year. So as you know, global installed base is about 40 million tons per year. So that's 4 years to replace the global installed base. But as you also know, I think Rystad has the number of projects under development at 600 million tons per year, which is hopefully where this industry is going. And in that context, of course, you see that this facility is, going to be an important provider of supply to the market. So we have the resources, the capital, the people. We've scaled up the team to over 280 people to undertake that. Again, to have the manufacturing plant in place and producing beds and demonstrating the quality and performance of that facility in advance of taking those purchase orders for first of a kind projects. That said, my title as Chief Revenue Officer is hyper focused on those projects. That's my day-to-day life, and we have really great candidates. Whether it's the project we're working on with Suncor at their Edmonton refinery, that's in the public domain, or other similar projects that we're working on in the United States. We're getting to a stage of engineering where we have line of sight and visibility towards an FID in 2025 on those plants, and operations, producing first CO2 in 2027 or 2028, which is really exciting for us. So, a significant amount of momentum, a significant amount of engineering dollars being spent, and a lot of confidence from our customers in our ability to do that scale up, given the progress they can already see today tangibly around both the machine, and the equipment scale up, but also the manufacturing capacity.
Yeah, there's huge potential, that's for sure. And it's exciting to see a company like Svante taking such a, a deliberate approach and a market-based approach, really, too, to kind of make sure things work properly and all the necessary steps are coming together. Nice. Do you have anything to add that we haven't covered or we didn't touch on earlier?
No, I think just my overall comment around the technology piece is whether it's the first generation technologies, the liquid amine providers, whether it's second generation technologies like ourselves, I don't think carbon capture is anymore a technology problem. It is now a matter of deployment, of having the right carbon pricing in place, the regulatory environments, things like we see now in Canada and the US, and I think that need to be repeated more globally, whether it be the ITC in Canada and our federal carbon price, or the 45Q, incentives that we have in the United States. These are the things that really need to be now demonstrated. So their policy right now, we need to see successful projects actually utilize them and demonstrate to everybody else that this is possible. So it's really about execution, policy, and regulatory. There's no shortage of carbon emissions to go after, right? When you think about the scale of this market, what it needs to be by mid-century to meet any of our climate goals, we're talking about several gigatons, even 10 gigatons by 2050 of carbon capture and removal. When you look at the number of facilities that implies, at some point we've got to be building, 100 plants a year or more. That's 2 plants a week. That's been done before in the world, whether it be the ethanol industry and when that happened in the United States, or whether it be power plants globally in places like China. The world's done that before, but not too often. It needs a real concerted effort. It needs the right incentives in place, and it needs a partnership approach. From our standpoint, that's why having an ecosystem and working in partnership with the industrial leaders that want to make a difference is so critical. You'll see in our news page, whether it be BASF, 3M, GE, Chevron, and many other names, Samsung on the investor side, or whether it be our partnerships like with Kiewit on the EPC side in North America. This partnership approach and not going it alone, I think, is critical. Because in order to take on that size of challenge, you need all of the expertise that are available. So that's probably my last plug to say that Svante is not trying to do this by ourselves. We're really trying to be a facilitator and enabler. We think we have a really unique technology and business platform, but ultimately are working together with others to make it happen.
Yes, exactly. No, that's a good note to end on. It is a huge effort that takes a lot of different collaboration, and CCS, is a key tool, but not the only tool in the toolbox to reach net zero as well. So yeah, exciting times for Svante and for the rest of the industry. So I appreciate you taking the time to explain it to us more, and we look forward to chatting with you in the future.
Absolutely. Thanks a lot, Grady. Really appreciate the conversation.